So this rock is the closest we have come to finding life on Mars. It was discovered by NASA's Perseverance rover in the Naratwa Valley's river channel in the Jezero crater. So this river channel once carried a river into the crater some 3.5 billion years ago. This rock contains many features that are potential biological signatures of ancient microbial life on Mars. So running across the length of this rock are these white stripes of calcium sulfate veins. We know from Earth that these veins are formed at the subsurface level when the mineral-rich groundwater seeps in through tiny fractures in the rock. The minerals get deposited and precipitate out, filling up the cracks. And so this rock on Mars must have been submerged underwater some hundreds of millions of years ago. But we have seen these calcium sulfate veins on Mars before as well. But the Perseverance rover has also found the presence of micromolecular carbon compounds in this rock, which are cross-linked three-dimensional networks of carbon chains and rings. We know from Earth that similar compounds are formed in organic matter like kerosene. They are also found in coal. They result from the decaying of the ancient plant and animal matter on Earth. But they could also be formed abiotically. But Perseverance rover has found something more. Between these white stripes of calcium sulfate veins are these reddish bands which contain the mineral hematite. This mineral is found abundantly on Mars and it what gives Mars its iconic red color. Now this hematite mineral contains the iron in the trivalent oxidation state Fe3+. Now if this rock was submerged underwater in oxygen deprived conditions and if there were microorganisms on Mars, then they could perform a reduction reaction on this rock and reduce the Fe3+ iron into Fe2+ ferrous iron. Now this ferrous iron is soluble in water. It could dissolve in the nearby water. The reaction that strips off the reddish color from the rock and the bleached spots on this rock could be the result of the same reduction reaction. We know from Earth that same reduction reaction occurs in the red rocks, also called red beds. Now if the decaying organic matter contains phosphorus, then the dissolved Fe2+ ferrous iron could react with that phosphorus to result in the hydrated iron phosphate, which is the mineral vivianite. And on Earth, this mineral is mostly found around decaying organic matter. And Perseverance rover has detected this mineral vivianite in these dark outlines around these bleached spots, as well as in the dark spots separately that are called poppy seeds. And these bleached spots with dark outlines are named as leopard spots because they are similar to the spots we find on leopards. In the dark outline, Perseverance rover has also found another mineral, greigite or iron sulfide. Now, greigite could also be formed by some microorganisms on Earth, although these spots could also be formed abiotically. But combining all of these features in this rock, the fact that it is formed in the ancient river channel, the presence of calcium sulfate veins, which could mean that this rock was in contact with the water, the presence of macromolecular carbon compounds, which very often result from the decaying organic matter on Earth, as well as the reduction spots that could have been due to the action of microorganisms on this rock. And so all of these features combined is what makes this rock as containing a potential biosignature of life. And the Perseverance rover has collected the sample, which has been named as Sapphire Canyon, and that sample awaits a future return to Earth.